Morning. Let's look at the next section of this chapter. So we have talked about energy. We have also understand that energy must be conserved. That means it only change from one form to the other. You cannot create, you cannot destroy it. It must always be transformed from one another. It's always constant. So now we'll talk about what we can use this energy for. Remember, energy is also allow us to do work. Let's find out more about work. So what is work? The work done by a constant force on an object is the product of a force and the distance moved by the object in the direction of the force. Now, this is very important. You must know the definition. So what does it mean? It simply means that the work done by the force on an object is a product. That means there must be a multiply of the force and the distance moved by the object. So in this case, the distance moved is s. We use s to symbolize the distance moved. And there's a criteria. This distance must be in the direction of the force. So you must take note, it must be in the direction of the force. So this is a formula, W equals to F times S. So what is the units? Force is newtons. S is in meters because there's distance, and work done is in joules also. Okay, so how do we understand through a picture itself? So if I have a ball here, I exert a force. In this case, I exert a force on it. Okay, I exert a force on it. What will happen? This object will move, and in this direction of motion is the same direction as your force. Can you see? The force and direction of motion is in the same direction. You can only multiply the direction or the distance if this distance is in the same direction. So I can take F times this distance S, because the direction that he moved must be in the direction of the force, or what we call as parallel. We'll do more example. If you're not very clear, don't worry, we'll do more example. So the SI unit for work or work done is joule, capital J. Please take note. 1 joule is defined as the work done by a force of 1 Newton, which moves an object through a distance of 1 meter in the direction of the force. So 1 joule is equal to 1 Newton times 1 meter. Example, work done equals to force and distance moved forward. So in this case, this person is pushing the pram. The pram, she exerts a force. I don't like this force here because it is not touching the object. Remember, your force must always touch the object. So she pushed forward the pram. What happens? The stroller moves in the direction of the force in this direction. So yes, there will be work done because the force times this distance here. Okay, next. However, there is no work done when the following situation happened. So let's take a look at this person. The direction of the applied force, he applied a force, remember must touch the object when you have a force, of his hand on the book is upwards. Okay. However, he is moving in this direction to the right. So this is S. Okay. Since the force and the direction is not in the same direction, they are perpendicular in this case. Okay. What happens is work done will be automatically equals to 0. Why? So let's put in the formula. Work done is equals to force times distance. So always write down the formula first. In this case, the force is F. What is the distance? Is there any distance in this direction here? So it does not only have to be up, it can be down. Any along this vertical direction. Is there any force in this up-down direction? No. So there is no direction of movement when it's top or down. So in this case, your distance moved in the direction is 0. Why 0? Because remember your S, the distance must be not this. Remember from your formula, your distance must always move in the direction of the force. So if my force is going up, my force is going up, is there any movement up or down? No, because they only say this guy moved to the right. So in this case, there is 0 joules. All right, so is this clear? No work is done if they are not in the same direction. Next, no work is done also in the following scenario. So the force is applied on the object. So this person pushed the tree here. I don't like this force because it's not touching also. uh, but the object does not move, so there is no motion. Okay, there is no motion. So W equals to force times distance. If you have a force, you exert a very big force to push this tree, but this tree never move. So your distance move is 0. In this case, so it's 0 joule. Next, if the girl is holding on to a heavy pile of books in a stationary room, stationary means never move. If it never moves, similarly, this thing comes in again because the girl can put a lot of force upwards, but the book never move. She never moved. There is no movement. Okay, remember the movement direction and the force must be in the same direction before we can multiply. Okay, let's look at one example. A boy pushes a box across a rough horizontal surface. He exerts 5 newtons to move it 2 meters. What is the work done by the boy? So he exerts 5 newtons. This is the force on the box. The box move 2 meters. This is the distance. So we write down the formula. W equals to force times distance. So the force is 5 newton. The distance is 2 meters. So he put 10 joules. Easy. Make sure they must be in the same direction. Next. A boy pulls a 1 kg wagon along a smooth horizontal floor over a distance of 5 meters. If the speed of the wagon increases at a constant rate of 2 meters per second, what is the work done by the boy? So in this case itself, let's look at the net force first. Okay, so we know that he is moving at a constant rate of 2 meters per second square. Sorry, we know that his acceleration is 2 meters per second square. Why? Because we look at the units, meters per second minus 2, this is acceleration. So we can immediately first find the force. Okay, why must we find the force? Because work done is equal to force times distance. We do not know the force that this boy pulling on the toy wagon is. So we need to find the force. So we know that the wagon moves at this acceleration. So we know F equals to ma. The wagon is 1 kg. The wagon is moving at this acceleration. We can find that the force exerted by the boy on the wagon, this is force by boy on wagon, is equal to 2 newtons. So the boy exerts a force of 2 newtons. So they say, what is the work done by the boy? So we know that the boy does 2 newtons. Then we need to know what is the distance that this wagon moves. Make sure that this must be in the same direction. Okay, you always say the boy pull and then he move along a horizontal floor, means he's in the same direction of 5. So you need times 5 meter. In this case, this will be 10 joules. Okay, so we can use 2 newtons directly because there is no resistance on the floor because the floor is smooth. As such, the only force on the wagon by the boy is 2 newtons. We don't have to consider for other frictional areas. Okay, so with that, this is an example of how we can use work done. If you are confused, always just rewind back to the segment where we talk about work done and then run it through one more time. Do the practice in your theory workbook and it will help a lot. All right, thank you.